Right now, as you listen to this, approximately 7 billion atoms inside your chest are holding their shape. Each electron locked in a stable orbit, each nucleus undisturbed, every one of them keeping its distance, keeping its bond, keeping the quiet architecture that lets your lungs rise and fall without your ever having to ask them to. And the only reason they can do any of that, the only reason you are here, lying still in the dark, is that the space around you has exactly 3 dimensions. Paul Ehrenfest showed this in 1918. In 4 spatial dimensions, the forces that hold matter together, gravity and electricity alike, would follow a different law. A law that offers no stable orbit anywhere. The electrons would spiral inward. Every atom in your body would fold in on itself and collapse. In 4 dimensions there is no chemistry, no biology, no slow rise of a chest in a dark room. No you, lying here listening to this. 3 is not simply the default. It is not a coincidence. It is not a law handed down in advance. And it is not an emptiness that happened, by luck, to have the right shape. Here is what most people get wrong about it. They assume space has 3 dimensions the way a triangle has 3 sides, by definition, as though nothing else were even possible. It is not like that. 3 dimensions is not a rule of language. It is a fact about physics, and a fact about physics has to have a reason. Consider how strange the hiding places are. Oscar Klein estimated in 1926 that if there are other dimensions, they would be curled up small, approximately 10 to the negative 30 centimeters small, 100 billion times smaller than a single proton. Our most powerful instrument, the Large Hadron Collider, reaches down to 10 to the negative 17 centimeters and still falls 13 orders of magnitude short of ever seeing them. That gap is the difference between the width of a human hair and the width of the whole observable universe. If those dimensions are there, they are folded away beneath everything, and we cannot touch them. And yet the deeper you look, the less settled the number becomes. A supercomputer, running the equations of string theory from a beginning with 9 dimensions, all of them equal, watched exactly 3 of them expand while the other 6 stayed frozen shut. A spontaneous choice, made at a single critical moment, that the mathematics never predicted in advance. A thermodynamic study, in 2016, found that a certain energy of the early universe reaches its very first peak at exactly 3 spatial dimensions, and only below 1 particular temperature. The universe may have locked itself into 3 the way still water locks into ice. Once. All at once. Never again to try another shape. Over the next few hours, we are going to follow every thread of that, slowly with nowhere to be. The stability that lets a single atom exist. The dimensions that may be hiding just out of reach. What the supercomputer saw when it finally counted. And the one temperature that may have quietly decided everything, long before there was anyone here to notice. If a slow journey like that sounds worth staying with, take a moment before we go any further to follow gravity of sleep. That is all it takes to be here again tomorrow night for the next one of these. No need to do anything now, but let the thought pass by. Then, let it go. Get comfortable. Let your weight settle down into whatever is holding you, the mattress, the pillow, the dark. Let your shoulders come down from wherever they have been all day. None of this is anything you need to remember. None of it will be on any test. You do not have to follow the numbers. You only have to let them move through you, quietly, one at a time, and fall away. Just listen. Let's begin. Start with the room. Not the universe yet, not the deep sky, only the small dark space you are resting in. It has a length. It has a width. It has a height. 3 measurements, and with those 3 you can find any point inside it. The corner above your head, the floor beneath the bed, the far side of the door. You could move up, or you could move down. You could move to your left, or to your right. You could move toward the far wall, or back the way you came. And that is all. There is no other way to go. There is no 4th direction waiting somewhere, No hidden turn you have simply never taken. Everything you have ever reached, you reached with some blend of those three moves, and nothing more was ever required. This is what a dimension is, underneath the word. Not something strange, not something mathematical, only an independent direction you are free to move in. Up and down is one, side to side is another, forward and back is the third. Three clean directions, set at right angles to one another, and the whole of your life has been lived inside them. Every step you have taken, every reach of your arm, the slow rise of your chest right now, lifting a little and settling again. All of it, a small quiet motion in exactly three directions. And because it is all you have ever known, it feels like nothing. It feels obvious. Of course, space has three dimensions. The way water is wet and stone is hard. It seems less like a fact and more like the shape of the question itself, too plain to be worth asking. But that very flatness, that sense that it could not have been otherwise, is the thing that hides the mystery. The number 3 is not a given. It is an answer. And for almost the whole of human history, almost no one thought to ask what the question was. The first person to ask it as a hard question of physics, and to answer it with real rigor, was a man named Paul Ehrenfest. The year was 1918. The place was Amsterdam. The war that had swallowed Europe was in its final exhausted year, and Ehrenfest, a physicist known more for the sharpness of his questions than for any grand theory of his own, sat down to ask something that sounds almost childish until you try to answer it. Why 3? Not 4, not 2, not 17. Why does the space we live in have exactly 3 of these directions, and no more? He did not reach for philosophy. He reached for the laws already known, the laws of gravity and of electric force, and he did something quietly devastating with them. He asked what those laws would look like in a universe with more directions than ours, and then he checked, carefully, whether anything at all could survive there. Consider gravity first, the way you already know it without knowing that you know it. The pull of the Earth on the Moon, the pull of the Sun on the Earth. In our 3 directions, that pull weakens with distance in one very particular way. Double the distance between 2 things, and the pull drops to 1/4 of its strength. Triple the distance, and it falls to 1/9. The force fades with the square of how far apart they are. This is the rule that holds the planets in their long, patient loops. It is gentle enough and forgiving enough that a world can settle into an orbit and simply stay there, going around and around for billions of years, without falling in and without drifting away. Ehrenfest showed that this forgiveness is a gift of the number 3. Add a 4th direction to space, and the arithmetic of the force shifts underneath everything. The pull no longer weakens with the square of the distance, it weakens with the cube. Move a planet a little too close, and the grip tightens far too fast, and the planet spirals down into the fire. Move it a little too far, and the grip goes slack too soon, and the planet drifts off into the dark, never to return. There is no comfortable middle, there is no stable path. In a universe with 4 directions of space, there are no lasting orbits at all. Not for planets, not for moons, not for anything held by gravity in a steady circle. The heavens in 4 dimensions would not hold still long enough to be called heavens. And it was not only the large that fell apart, it was the small as well. Ehrenfest turned the same question on the atom, on the single electron circling the nucleus, held there not by gravity but by electric attraction, which obeys the same kind of law. In 3 directions, an electron can find a stable place to be, a steady distance to keep, and so an atom can exist and hold its shape. Give space a 4th direction, and that stability vanishes in exactly the same way. The electron would spiral inward and fall into the heart of the atom in a single instant. No stable atoms. And without stable atoms, no molecules. Without molecules, no chemistry. Without chemistry, nothing that could ever grow, or think, or lie awake in the dark listening to a voice describe all this. Rest there for a moment. Not on the mathematics, which you can let go of entirely, but on the strange smallness of what it means. Every atom in your body is holding together right now, because space has 3 directions and not 4. The bonds that lace your bones together, the long, folded twist of the code inside your cells, the soft machinery in your chest, breathing without being asked to. All of it standing, all of it holding, on a foundation exactly 3 directions wide. One more direction, and none of it could have formed. The universe would be a place where nothing sticks, where matter can never gather itself into anything lasting. A smooth and empty churn with nowhere for a world to settle, and no way for a single atom to keep its shape. That was Ehrenfest's answer, and it was a beautiful one. But notice what kind of answer it is. It does not say the universe was built with 3 directions on purpose. It does not say a hand reached in and chose the number. It says only this: in a universe with more than 3, there would be no one there to notice the difference, because no stable thing could exist to do the noticing. We find ourselves in 3 dimensions, because 3 dimensions is the only kind of place that can ever hold a finder. It is less a reason than a filter. Of all the ways a universe might have been, we could only ever wake up inside the narrow kind that lets waking happen at all. For a while, that was where the matter rested. 3 was not a mystery to be cracked, but a condition to be grateful for, a lucky flaw beneath everything else, and it might have stayed a quiet footnote, a small curiosity for physicists to nod at and move past, if the story had ended there. It did not end there, because almost as soon as the question of why there are only 3 had been asked, a stranger question came knocking, from the opposite direction entirely. The knock came in April of 1919, only months after Ehrenfest's paper, and it came in the form of a letter. It was written by a nearly unknown German mathematician named Theodor Kaluza, and it was addressed to the most famous scientist alive, Albert Einstein, whose new theory of gravity was just then being confirmed by the bending of starlight, and was about to make him a household name across the entire world. Kaluza's letter did not ask why space has only 3 dimensions. It asked something almost heretical. What if it has more? What if there is a 4th direction of space that we simply cannot see? And what if that hidden direction is not a flaw in the picture, but the missing piece of it? Kaluza had been quietly playing with Einstein's own equations, the ones that describe gravity as the bending of space and time, and he had tried something that sounds on its face like a plain mistake. He wrote those equations out as though space had not 3 directions but 4. 1 extra. A direction with no name and no obvious place to point. And when he did, something fell out of the mathematics that had no business being there. Out of the equations for a gravity with 1 extra dimension came, unbidden and whole, the equations for electricity and magnetism, the other great force known to physics, the force of light and lightning, and every current that has ever run along a wire simply appeared on its own, as though it had been folded inside that extra direction all along, waiting there to be unrolled. Einstein read the letter and felt both its pull and its danger. Here was a way to braid the 2 known forces of nature into a single thread, gravity and electricity woven from the same cloth, and all it asked in return was 1 more dimension than anyone had ever seen. He held the idea at arm's length for 2 long years, uneasy, unwilling to let it go and unwilling to bless it, before he finally helped bring it into print. And it left behind a question that would not lie down. If there truly is a 4th direction of space, quietly doing the work of holding light together, then where has it gone? Why has no one ever stepped even a little way into it? Why can you not point, right now, from where you are lying, toward a direction that is supposed to be as real as up and as real as forward, and yet has never once let you in? That question hung in the air for years, unanswered, and the man who finally reached for it was a quiet Swede named Oskar Klein. In 1926, in the pages of a German physics journal, he gave an answer so simple and so strange that physicists still lean on it today, nearly a century on. The 4th direction of space, Klein said, has not gone anywhere at all. It is here. It is everywhere. It runs through the room you are lying in, through the pillow beneath your head, through the small dark space between your resting fingers. You cannot point along it for one reason, and one reason only. It is rolled up too small to enter. Picture taking a wide, flat sheet of paper and rolling it, tighter and tighter, into a tube. Roll it far enough, and the tube grows so thin that from across the room it looks like nothing more than a single drawn line. A garden hose seen from a hillside looks like a thread lying in the grass, and only an ant walking along it knows the truth, that there is a whole second direction wrapped around under its feet, a direction it can circle again and again. Klein imagined the fourth direction of space curled exactly like that, not stretched out before you, but wound into a loop so tight that nothing you will ever hold could travel the whole way around it. And then he did the thing that makes a physicist a physicist. He put a number on the size of that loop. It is a smallness that has no comparison in ordinary life, so let the number stay soft for a moment, and then let it become real. A proton, one of the small hard grains sitting at the heart of every atom in your body, is already so small that you could lay 100 million of them end to end and still not cross the width of a single grain of sand. Klein's curled direction is smaller than that proton, not by a little, but by about 100 billion times. It is only around 24 times larger than the smallest length that physics believes carries any meaning at all, the length beneath which the very words distance and size stop making sense. That is where he hid an entire direction of space, not far away across the sky, just far down. Down past every scale your hands have ever touched, folded into a circle so tight that a beam of light set loose inside it would race all the way around and arrive back where it began before it had gone anywhere you could measure. You do not need to carry that number with you. Let it loosen and drift off. It is enough tonight to simply know this. The world around you feels wide and open and roomy, and it may be resting quietly on top of other rooms, folded rooms, far too small to ever step inside. That thought asks nothing of you now, only that you hear it once and let it go, and let your shoulders sink a little deeper into the bed as it passes. Klein had given physics a word it never gave back: compactification, a dimension made real and yet hidden, wound away in a place where nothing large can follow. And once you hold that word, once you can picture a whole direction folded down beneath all seeing, a door swings open that will not close again. Because if one dimension can hide that way, there is no law written anywhere that says only one of them did. For a long while the idea drifted at the quiet edges of physics. Almost 60 years it lingered there, too lovely to throw out and too strange to build anything upon, admired and set aside. And then, in the middle of the 1980s, it came roaring back with a force no one had asked for. In 1984 and 1985, in a rush of work that physicists to this day call the first superstring revolution, a wholly new picture of matter took hold. In this picture, the smallest things that exist are not tiny points at all. They are tiny strings, threads of pure energy, vibrating, so much smaller than an atom that they make Klein's curled dimension look almost spacious by comparison. And when the equations of these strings were finally written down and asked one plain question: how many directions of space do you need in order to hold together without contradiction? They did not answer 3. They did not answer 4. They answered 9. 9 directions of space and a tenth of time. 10 dimensions in all. Rest on the shape of that for a moment. The most ambitious theory anyone had ever dared to write, a theory meant to hold matter and light and force and gravity all in a single hand, would only stand up if the universe carried 9 directions of space. You move through 3. The other 6, the theory said, must be curled away exactly as Klein had curled his one, folded into shapes so small and so intricate that you pass through them countless times over with every slow breath and never feel the faintest thing. Those folded shapes were given a name of their own: Calabi-Yau manifolds, 6-dimensional origami, tucked invisibly into every single point of the space around your bed, each one a closed little world holding its own private geometry. And here, gently, the wonder begins to cool into something colder, because in 1995, a physicist named Edward Witten stood before a room of his peers and showed them that the 5 rival versions of string theory, each one its own 10-dimensional story, were not rivals after all. They were 5 faces of a single deeper theory beneath them all. He called it M theory. He never quite said aloud what the M was meant to stand for, and this deeper theory did not shrink the count of dimensions. It grew it. 11 now, 10 directions of space and 1 of time. One more direction, folded away into the dark, and then comes the number that ought to keep a physicist lying awake at night. Though tonight, please, let it only wash over you and move on. When theorists tried to count the different ways those hidden dimensions might be folded, the different Calabi-Yau shapes the universe could have settled into, they did not find a handful of them. They did not find thousands or millions. They found something closer to a 1 followed by 500 zeros. More possible foldings than there are atoms in all the visible universe. More than there are grains of sand on every shore of every world that has ever formed around every star. Each folding a different universe, each with its own particles, its own forces, its own quiet laws. And the theory, for all its shining beauty, still cannot tell us which of those countless foldings is ours. It cannot tell us why the 3 wide directions you can drift through tonight are the 3 that stayed open, while all the others fell shut. And so, after Ehrenfest, and after Kaluza, and after Klein, after the strings and the revolutions and the growing count of 11 silent dimensions, the number 3 had not truly been explained at all. It had only been buried deeper, under more mathematics, and more hidden directions, and more silence, until the plainest fact about the room you are resting in, that it has a length, and a width, and a height, and nothing more, had quietly become the single greatest unanswered question in all of physics. But a question left unhidden is not the same as a question abandoned, and a little more than 100 years after that first quiet proof, in the year 1989, in the pages of a journal called Nuclear Physics B, 2 physicists set down an idea that did not try to explain the number 3 by counting what we can see around us. They did something stranger, and softer, and far more patient. They tried to explain the 3 directions of your room by rewinding the film, all the way back. Back past the stars, back past the first light, back to the earliest faint instant of everything, when space itself was not yet wide, and had not yet chosen how wide to become. And they asked a smaller question than the one everyone else was asking. Not why space has 3 large dimensions now, but how it came to keep only 3 then in the very first moment, when it was still deciding. Their names were Robert Brandenberger and Cumrun Vafa. The paper they wrote was not long, only some 20 pages, and its title was as plain as a weather report: Superstrings in the Early Universe. But inside those pages was a picture of the beginning that no one had drawn in quite that way before. Picture it now, gently, the way you might picture a story you are being read as you fall asleep. In the very beginning, they said, there were not 3 large dimensions and 6 small ones. There were 9 dimensions, and all of them were small. All of them equal. All of them curled up tight, each one wound into a tiny loop, the way you might roll a long sheet of paper into a thin closed tube. Not 3 wide roads and 6 locked doors. 9 tiny loops, indistinguishable, none of them yet grown, none of them yet chosen. A universe the size of almost nothing, folded evenly in every direction at once. And through this folded, humming beginning ran strings. Not the vibrating threads of matter we have already spoken of tonight, or not only those. In this early state the universe was filled with them, a dense warm gas of strings, and this is why the idea came to be called, quite tenderly, string gas cosmology. Some of those strings did what strings do. They floated, they vibrated, they carried energy. But some of them did something else. something they can only do when the dimensions are small. They wrapped around them. Imagine a rubber band stretched around a rolled poster, hugging the tube, wound about it so that it cannot slip off the ends, because there are no ends. In a universe where every dimension is a closed little loop, a string can wind itself around that loop, once or twice or many times, and hold there. Physicists call these the winding strings, or the winding modes, and they matter more than almost anything else in this story, because of one simple thing they do. They hold the dimension small. Here is the heart of it, and it is worth resting on, so let yourself rest on it. A winding string is under tension, like that stretched rubber band, and it wants to shrink, and as long as it is wrapped around a dimension, it pulls that dimension inward and refuses to let it grow. So for any one of those 9 loops to open up, to unfurl, to become a wide direction you could one day drift through, the strings wound around it have to come undone. They cannot simply loosen, they have to be undone. And the only way a winding string can be undone is to meet another string wound the opposite way, its mirror, its partner, so that the two of them touch and cancel, and release their tension as a small flare of energy and vanish. When a winding string meets its opposite, both unwind at once. The knot comes free, and only then, with nothing left hugging it tight, can that dimension begin to swell. So the whole question, the question of how many dimensions grow large, becomes a much humbler question. It becomes a question of meeting. In how many dimensions can 2 wandering strings actually find each other, and touch and untie? And this is where the beauty of the argument arrives, quiet and clean, resting on nothing more than the plain geometry of things passing through space. Think of a single point moving through the world. As it moves, it traces a line, a thread of where it has been. Now think of a string, which is not a point but a line already, a thread in its own right. As that thread moves through time, it does not trace a line. It sweeps out a surface, a sheet, the way a moving pencil drags out a smear. A one-dimensional string, moving, paints a 2-dimensional sheet behind it. And now ask the simplest thing. For 2 of these sheets to cross, for 2 winding strings to genuinely meet and untie each other, how much room can the space around them have? Picture 2 ships on the flat surface of an ocean. Their paths are lines on a plane, and lines on a plane, if they are not perfectly parallel, will cross. The ships can find each other. Now lift them off the water. Picture 2 birds in the open sky, each free to move not just across but up and down as well, through the whole 3-dimensional volume of the air. 2 birds can fly for a lifetime and never once share a point of space. Add room, and things stop meeting. Add dimensions, and the wandering threads slip past one another forever, blind, untouched, still wound. When the physicists did this counting carefully, for strings, the answer that fell out was 3. In a space of 3 dimensions or fewer, the sweeping sheets of 2 winding strings will generically cross. The strings will find each other, they will untie. But in 4 dimensions, or 5, or all the way up to 9, they drift past, endlessly, and never meet, and stay wound, and hold their dimensions small. 3 is not a lucky number here. 3 is the largest number of dimensions in which strings can still find their partners and come undone. It is the ceiling. It is the widest a space can be, and still let the knots release. And so, in the earliest instant, something quietly unfair happened, and the unfairness is the whole point. In 3 of the 9 directions, the winding strings met, and annihilated, and released their grip, and those 3 directions were suddenly free, and they began to grow. They stretched, and became the length, and the width, and the height of everything that would ever come after. But in the other 6, the strings never found each other. 6 directions kept their winding strings wound tight around them, kept their tension, kept their loops closed, and stayed small. Not chosen for greatness, simply never released. 3 came loose and became the world. 6 stayed knotted and became the hidden folds we can no longer feel. Let that settle over you for a moment, because it is one of the gentlest answers physics has ever offered to a question this large. There is no designer in it. There is no fine-tuning, no dial set carefully to 3 by a careful hand. There is only a warm, crowded beginning, and a rule about meeting, and the plain fact that threads can find each other in 3 dimensions, but lose each other in more. The number 3, in this telling, is not a law written into the universe. It is the outcome of a traffic problem in the first flicker of time. 3 is simply how many lanes were narrow enough for the cars to keep colliding, and here is where it reaches you, resting there in the dark. The 3 directions of the room around you, the length of the wall your bed sits against, the width of the ceiling above you, the height from the floor to that ceiling. These are not 3 directions out of many that happen to be handed to you. They are the 3 where, in the first instant of everything, the knots could come undone. Your body lies along them now. When you breathe in, your chest rises through the one direction that grew tall. When you turn, gently, onto your side, you are moving through the ones that spread wide. Every reach of your arm, every slow settling of your shoulders into the mattress, travels only through the 3 dimensions where the ancient strings once managed to meet. The other 6 are still here, folded beneath everything, wound as tightly as they were at the start, too small to move through, too small to notice, holding their tension in silence under the surface of the world you can stretch out in. You do not need to hold any of this. Let the picture soften, let the 9 little loops blur, and the strings, and the meeting and the not meeting, and let only the feeling of it remain, the feeling that the openness around you was once a decision the universe made, without knowing it was deciding, that the space you are lying in was won, not given, that 3 directions were let loose while 6 were held down, and that you are made entirely of the loose ones, drifting freely tonight through exactly the dimensions that came undone. It was a beautiful idea, and it was more than an idea, because for the first time it was a mechanism, not a selection made after the fact, not a shrug of it simply had to be this way for us to be here. An actual physical process, with a topological reason underneath it, a reason you could almost draw on the back of your hand. And yet a mechanism, however lovely, is still only a story until something outside our own heads agrees with it. The strings could not be seen, the beginning could not be visited. And so the question that came next was the hardest one of all. Was there any way at all, to watch 3 dimensions break free, and count them, without simply trusting that they must? The answer, when it finally came, did not come from a telescope. It came from a machine whose only talent is counting, patiently, in the dark, one small step after another, the way you might be counting your own breaths tonight without ever deciding to. In the summer of 2011, 3 physicists set out to do something that 100 years earlier would have sounded like a quiet kind of madness. One was named Sang-Woo Kim, working in Osaka. Another was Jun Nishimura at a Japanese national laboratory called Keck. The third was Asato Tsuchiya in Shizuoka. They were not hunting for the number 3. They had no wish to prove that our world was inevitable, no hope pinned on any particular outcome. They wanted only to take the rawest, most honest form of string theory, the version with nothing added and nothing assumed, and let it speak for itself. The form they chose is called a matrix model. You do not need to picture the mathematics. You only need to picture the starting point, because the starting point is the whole beauty of it. They began with 9 spatial directions, and they made them exactly equal. Not 3 large ones and 6 small ones. Not our familiar length and width and depth standing tall while the others stayed hidden. 9 directions, all the same size, all the same weight, all as real and as open as one another. A perfect featureless balance, with no up, no down, no here, no there, nothing to tell one direction from the next. If you had somehow lived inside that starting condition, you could not have said which way was forward, because every way was forward equally. Then, they let it run. The method they used has a name that gives away its temperament. Monte Carlo, after the casino, because at its heart it works by throwing dice. Millions upon millions of tiny random rolls, each one nudging the numbers a little, letting the equations feel their way toward whatever state they most wanted to settle into. No hand on the wheel, no hidden instruction whispering, "Let 3 of you grow." The physicists did not tell the universe how many dimensions to keep. They simply asked the mathematics what it would do if left alone, and then they waited while the supercomputer rolled its dice, quietly, for a very long time. For a while, in the simulated past, nothing broke. The 9 directions stayed balanced, equal, symmetric, the way still water stays flat until something touches it. And then, at a particular moment the physicists came to call the critical time, the water moved. The symmetry cracked. Out of the 9 equal directions, 3 of them began to swell. They stretched, they opened, they pulled away from the others and kept pulling. And the remaining 6 did not follow. They stayed small, they stayed wound tight and shut, exactly as they had begun, while their 3 siblings expanded into something that looked more and more like room, like space, like a place where one thing could rest apart from another thing. 3. Not 2, not 4, not some shifting uncertain count that came out differently each time they ran it. 3, arising on its own, from a beginning that had shown no preference for 3 at all. Rest with that for a moment, softly, the way you would rest with a strange line in a story read aloud after the lights are out. Nobody put the 3 there. The number was not written into the setup. The equations began in a perfect 9-fold fairness, and left entirely to themselves, with only the roll of the dice to guide them, they chose our number. A grand balance, in which all 9 directions were the same, quietly collapsing into a smaller one, in which only 3 could grow. The physicists had built a seed of the earliest universe out of pure mathematics, planted it inside a machine, and watched 3 dimensions come loose while 6 held fast. They wrote it down carefully, without fanfare, the way careful people do. The paper went out into the world in the August of 2011, was gone over again and corrected the following spring, and was printed in a journal called Physical Review Letters in 2012. It is a short paper, its title is dry, and inside it sits one of the more astonishing sentences a person can read while half asleep, which is that a computer, beginning from 9 directions that were all the same, watched exactly 3 of them break free, and the 3 it found were ours. Now, be gentle with what this is, and be gentle with what it is not. It is not a photograph of creation. No one filmed the birth of space. What they built was a distillation, a boiled-down essence of the theory, small enough to fit inside a machine, and simple enough to actually solve. It is a model, and models can be wrong, and the people who made this one would be the first to tell you so, quietly, in the same measured voice. But something had happened that had never happened before. For the first time, the number 3 had not been assumed, had not been reasoned toward, had not been argued for on the grounds that we could only be here if it were true. It had emerged. It had come out the far end of a calculation that did not know we were watching, and did not care whether we lived. And here is where it reaches you, lying still in the dark. Somewhere in a cooled room, in a rack of humming metal, a machine held a tiny, honest fragment of the laws that made everything, and it let those laws run their course. And out of a perfect balance of 9, 3 came free. Those 3 are the 3 you are resting in right now. The length of your body along the bed, the width of your shoulders, the small height of your chest as it rises and falls. Each of those is one of the loose directions, one of the 3 that swelled and ran while the other 6 stayed folded shut so far below your notice that no instrument you will ever meet could find them. You are not merely living in 3 dimensions. You are made of the ones that got away. You are the outcome of that ancient breaking, stretched thin across the very directions that came undone. It should feel enormous, and perhaps, for a heartbeat, it does. But you do not have to hold it up. You do not have to carry the weight of 9 dimensions collapsing into 3 in order to fall asleep tonight. Let the number settle where it lands. Let the machine keep its dice. The 3 directions that came loose an unimaginably long time ago are still the same 3 cradling you now. Patient, unremarkable, entirely yours, asking nothing of you but that you rest inside them. And still, even now, even with a number that came unbidden out of honest mathematics, some careful part of the mind leans forward. Because a simulation is a world we built to answer us. Its dice are our dice. Its 9 directions were 9 because we told it 9. It is a magnificent hint, and a hint is not yet the thing itself. The real universe was under no obligation to obey the small one we made in our machines. So the question, softened but not silenced, turns over once more and points outward, past the computer, past the theory, toward the sky and the ground, and the enormous, unhelpful evidence of the world exactly as it is. And the world as it is offers no apology. It does not round itself down to 3, because 3 is tidy. It simply holds you, and holds the floor beneath your body, and holds the far light of every star you have ever looked up at, all with the same quiet indifference that a machine can only imitate. So the mind, having been handed a number by a simulation, does the honest thing. It turns away from the computer and toward the people who never left the real world at all. It turns toward the physicists who took the extra dimensions seriously, not as folded scraps too small to ever matter, but as something that might be genuinely, physically there. Vast, close, and merely out of reach. 2 of them in the same year took the whole question and turned it inside out. The year was 1999. The names were Lisa Randall and Raman Sundram, and what they proposed was so simple and so strange that it changes what the word around you even means. They did not ask why the extra dimensions are hidden. They asked why we would ever expect to feel them in the first place. And their answer was that you are not living inside space the way you have always assumed. You are living on it. On a surface, on a thin sheet suspended in something larger. Let that idea arrive slowly, because it does not need to frighten you to change you. Picture a single wide sheet, endless in the 3 directions you know, but with a thickness you cannot enter, an edge you cannot reach. A beyond that presses right up against you and yet stays sealed. In the language of the theory, that sheet has a name. It is called a brain, from the older word membrane, and the larger space it floats in is called the bulk. Everything you have ever touched, every particle of your body, every photon of light, is stuck to the brain, bound to it, unable to step off. The atoms in your hand cannot leave the sheet any more than a drawing can climb out of the paper it is drawn on. And so the extra dimension is not small. It may be enormous. You simply have no way to move into it, and never have. This was not built to be eerie. It was built to solve a problem that had haunted physics for decades. A problem so quiet that most people have never heard its name. It is the problem of why gravity is so unbelievably weak, and it is worth resting here for a moment. Because you already know this fact in your own body, you have just never been told to notice it. When you lift your hand off the blanket, you defeat the gravity of the entire planet beneath you. The whole Earth, every ocean and mountain and molten mile of it, pulls down on your arm, and a single tired muscle wins. That is how feeble gravity is. Set beside the force that holds an atom together, or the force that binds the light in a magnet, gravity is almost nothing at all. How weak. Put a number on it, and the number does not behave. The natural strength of gravity and the natural strength of the other forces are separated by about 16 orders of magnitude. That is a 1 with 16 zeros written after it, and a number that large will not sit still in the mind. So translate it into something the body already understands. Count 1 second for every unit in that gap, 1 second at a time, without sleeping, without stopping. and you would still be counting after more than 300 million years. You would have started counting before the first dinosaur, before the first flower opened anywhere on Earth, and you would only now be finishing. That is the distance between gravity and everything else. That is the silence physicists had no reason for. Let the size of it pass through you. You do not have to hold it. It was never yours to carry. For years there was no honest explanation for that gap. You could write it into the equations by hand, but writing a thing in by hand is a confession, not an answer. It means you have chosen the number rather than understood it. Physicists have a gentle, damning word for that. They call it fine-tuning, and they distrust it the way you would distrust a coincidence that is simply too clean. 16 orders of magnitude is far too clean to be a coincidence. Something had to be arranging it. Randall and Sundram offered the arrangement. In their first paper, published that year in the Journal of Record for their field, they imagined not one sheet but two brains, held apart by a single extra dimension curved and warped between them. And here is the quiet miracle of the design. The warping stretches distance and energy as you cross from one sheet to the other, stretches it smoothly, exponentially, the way a small twist near the base of a rope becomes an enormous sweep by the far end. On one brain sits the natural scale of gravity, colossal, the scale where space itself would tremble. On the other brain, our brain, that colossal number arrives softened, tamed, shrunk across the warp into the mild and ordinary energies of the everyday world. The 16 orders of magnitude are not written in by hand at all. They are what a short warped fifth dimension does to a number as it travels. The gap is not a mystery. The gap is a shadow, cast by a geometry you cannot see. Sit with how that reframes your own smallness. You had been told, perhaps, that gravity is weak, and no one knows why. And now there is a picture in which gravity is weak, because most of it is somewhere else. Because you and the whole visible world are pinned to a membrane, and the true strength of things lives on another sheet a single warped step away. A step in a direction that your body has no name for, and no hinge to turn toward. Not lost, not gone, just adjacent, in the one way you can never travel. Then, in a second paper the same year, the two of them did something that should have been impossible, and made it feel almost calm. They asked what would happen if that extra dimension were not short at all, not curled, not tiny, not a warp of finite length, but infinite, endless bulk, running away from our sheet forever. By every old instinct, an infinite extra dimension should be a catastrophe. Gravity would drain into it and dilute to nothing, and the careful clockwork of orbits and falling apples would fall apart. Instead, they found that the world would look exactly, perfectly, undetectably the same as the one you are lying in right now. The reason is the strangest and softest idea in this whole long night. Gravity, in their picture, is carried by a particle called the graviton, and a particle in physics is not truly a dot. It is a spread, a probability, a smear of where the thing is likely to be found. And the graviton smear, they showed, is pulled almost entirely down onto our brain. It clings to the sheet, its likelihood rises to a sharp peak right where we live, and then falls away exponentially into the bulk beyond, dropping so fast that only the faintest whisper of it ever reaches out into the endless dimension. So gravity behaves like a four-dimensional force, like the force you have known your whole life. Not because the extra dimension is small. The extra dimension might be infinite. Gravity behaves itself because the graviton is trapped here, with you, held against the sheet by the same warped geometry. Which means the deepest version of the answer flips one more time, and this may be the last flip before the quiet comes. Gravity is not weak because there is little of it. Gravity is not weak because the fifth dimension is short. Gravity is weak because it is localized, because it is bound. Because the one force that could, in principle, leak off the sheet and out into the greater space is held down almost completely. And what you feel of it, the small honest tug that keeps you in your bed tonight, is only the fraction that could not escape. If any part of it does slip away into the bulk, you would never miss it. You have only ever known the remainder. And if that is true, then the 3 dimensions are not the whole of space. They never were. They are a raft. A wide, thin raft riding on an ocean you cannot get wet in. And the reason the ocean has stayed invisible for the entire history of thought is not that it is small, and not that it is far. It is that you are made of things that cannot leave the raft. Your atoms are passengers with no ticket to anywhere else. Every love you have ever felt, every word you have ever spoken, every night you have ever lain down like this one and closed your eyes, all of it happened on the sheet, and could only ever have happened on the sheet, and the vastness beside it went on being vast the entire time. Patient, unreached, asking nothing. You do not have to be afraid of an ocean you cannot fall into. Notice that. Whatever presses against the edge of the world, it has held you gently your whole life without once letting you slip. Let your shoulders ease down into the sheet that carries you. Let the weight of your own small localized gravity settle you exactly where you are. The raft is enough. The raft has always been enough. But a picture this beautiful is still only a picture until the real world is made to speak. And there is one place, colder and more literal than any theory, where we finally stopped imagining membranes and started trying to catch one. That place is a ring of great magnets buried in the cold ground, where a machine built by thousands of patient hands over many patient years does one violent, delicate thing, over and over, all day and all night. It takes the smallest ordinary pieces of matter, the protons at the heart of hydrogen, the very same protons that sit inside every drop of water in your body, and it drives them faster and faster around that buried ring until they are moving at very nearly the speed of light. Then it turns 2 of these streams to face each other and lets a few of them meet head-on. We call it the Large Hadron Collider. It lives at a laboratory named CERN, and it is, as far as anyone can honestly say, the most powerful instrument our species has ever built to ask a single question. And the question it was made partly to ask is the one we have been circling gently all night. If there truly is another dimension folded against ours, if we really do live on a thin sheet inside a larger space, then perhaps, in a collision fierce enough, some faint trace of that larger space might show itself for the briefest instant. So the whole apparatus is aimed at concentrating an enormous amount of energy into a space smaller than a single atom, trillions of the tiny units physicists measure energy in, all crowded into one flash, on the chance that the flash might knock on a door we cannot otherwise see. There were 2 ways it might have shown. The first is the gentlest and the strangest. If gravity really does leak away from our sheet into the space beyond, as one picture of the brain quietly suggests, then in a hard enough collision a little energy might simply go missing, carried off by a single particle of gravity slipping out of our world and into the bulk, never to return. The detectors would see a collision that does not quite add up, a small deficit, an amount of energy that went somewhere the instruments cannot follow, and did not come back. The second way is louder. If the extra dimension is curled and finite, it would allow heavier echoes of the ordinary particle of gravity, a whole ladder of them, each rung a version of the graviton carrying more mass, a structure named after Kaluza and after Klein. One of these heavy gravitons, born for a flicker inside the machine, would fall apart almost at once into 2 photons flying back to back, or into 2 leptons, or into 2 bright sprays of particles. And the great detectors, the ones called Atlas and CMs, patient eyes the size of houses, would catch that sudden coincidence and know it for what it was. There was real reason to hope. In the years before the machine switched on, 3 physicists, Arkani Hamed, Dimopoulos and Varley, had put forward an idea bold enough to be tested. Perhaps the extra dimensions were not impossibly small after all. Perhaps they were large, larger than anyone had dared to guess, large enough that this machine might actually reach them, large enough to explain in one clean stroke why gravity is so absurdly, so tenderly weak next to every other force. If they were right, the collider would not merely hint at the hidden space, It would swing the door open and let us look straight in. So they looked. They ran the machine for years. They gathered collisions by the trillions and combed through every one of them for the small deficit, for the bright back-to-back flash, for any sign at all that our sheet was not the whole of the world. And here is the quiet, heavy fact at the center of tonight. They found nothing. Not nothing in the sense of a failure, nothing in the far colder sense of a clean, careful, repeated absence. By the summer of the year 2016, the searchers had swept upward through energy after energy and come back empty-handed. The heavy graviton of the warped picture was ruled out below almost 4 trillion electron volts, and for some versions of it below nearly 4.5 trillion, a wall of energy climbing higher with every month of new data. The large extra dimensions of that hopeful 3-name idea were pushed out past 2.5 trillion electron volts, then past 3, then out toward 4. Every place the machine could see, the hidden dimension was not. And even this great silence is not the end of how far the hiding goes. Remember the very first hidden dimension anyone imagined, the one Klein rolled up into a tiny circle a full century ago. That circle, if it is truly there, is smaller than the smallest thing this machine can resolve by a factor of 10 trillion. 10 trillion, not 10, not 10,000, not a million. That is the size of the gap. If you set out to count to 10 trillion, one number every second, never once pausing to eat or to sleep, you would still be counting long after 300,000 years had gone by. That is how far short the greatest machine we own falls of the smallest hidden dimension. It does not miss because it is weak. It falls short because the hiding place is that deep. And here is the turn that makes the whole beautiful picture feel small. If the extra dimension were only a little larger, we would have caught it by now. If gravity leaked just a little more freely, the detectors would have watched the energy vanish. If the heavy graviton were only a touch lighter, its bright flash would already be sitting in the record, and this would be a very different night, and a very different story I would be telling you. But every door the machine has opened onto the same clean emptiness. The theories are beautiful. The mathematics closes. The membranes and the warped space and the whole ladder of hidden gravitons all hang together with a rigor that took the finest minds of a century to build. And when we finally reached out with the most literal, coldest instrument we have ever made and asked the world to confirm even one of them, the world said nothing at all. You are allowed to find that restful rather than frightening. Nothing was taken from you tonight. The 3 dimensions you are lying inside are exactly as solid as they were an hour ago, holding your weight, holding the shape of the room, holding the slow rise and fall of your chest. The silence at the collider does not unmake the raft. It only tells you that if there is a wider sea, it keeps itself further off than we can yet wade. Let that distance be a comfort. Let the not knowing be a place you are allowed to rest, with no answer owed and nothing to solve before the morning. Breathe slowly. Let the machine keep its long vigil down in the cold ground without you. You do not have to keep watch tonight. Nobody is asking you to hold the question. You can simply set it down beside you and let it be heavy somewhere that is not your hands. But a silence this complete does something strange to a question. When you look outward with everything you have, with the largest and finest thing you have ever built, and you find no edge, no leak, no hidden door anywhere, the question quietly turns around and begins to face the other way. All along we had been asking where the other dimensions went, how they folded, how they curled themselves away out of sight. And slowly, underneath all of that searching, a different and much older question begins to rise, so gently you might not notice it arriving. It does not ask where the others are hiding at all. It asks something stranger and closer to the bone. Why these 3? Why only these 3? Why were exactly 3 of them ever allowed to open in the first place? It is such a small turning of the words. Where did the others go? Why did these 3 ever open? You could lay them side by side in a single slow breath and barely feel the floor shift beneath them. But they are not the same question in different clothing. They are opposite questions. The first one quietly assumes that 3 is the natural resting state of things, the ordinary baseline, the way a room is simply a room, and that the only mystery is the vanishing of everything else. The second question assumes nothing so comfortable. The second question looks at the number 3 and does not see a given at all. It sees a survivor, not the default, not the shape space was born wearing. Something that came through. Something that was left standing when the rest was not. And this is the turn. This is where the whole night bends around and starts walking in a new direction, and you can let it carry you, because you are not steering. For most of the last 100 years, the smartest people who ever thought about this treated our 3 dimensions as the fixed thing, and the extra ones as the puzzle. The extra dimensions were the intruders. They were the guests who had to be explained, folded, hidden, curled down below the reach of any instrument. 3 was home. 3 was where you started from. But somewhere in the late 1980s, a quieter and far stranger idea began to grow in the corners of theoretical physics. And it said, softly, that we had the whole thing backward. That we had been guarding the wrong door. Here is the thing almost everyone gets wrong, and you may have been carrying it yourself, gently, without ever choosing to. When you picture the early universe, the very young cosmos, you almost certainly picture a small space. A dense, hot, tiny space, but a space with 3 directions in it, already 3, just squeezed. A miniature version of the room you are lying in now, waiting to be inflated to full size like a held breath. That picture feels obvious. It feels like it could not be otherwise. And it is wrong, not slightly wrong. Wrong at the root. In the beginning, according to this idea, there was no roominess to speak of in any direction. There was no wide and no narrow. Every direction was the same. Every direction was small. Not 3 big ones and some small ones tucked away, but 9, all alike, all folded down to nearly nothing. A knot with no favoured way to unfold. The question was never why 6 dimensions hid themselves. The question was why any of them ever grew. Sit with that for a moment, because it inverts everything. You do not have to hold it tightly. Let it rest on you the way a blanket rests, with its own weight, asking nothing. In this picture, the strange thing is not the smallness of the extra dimensions. The strange thing is the largeness of ours. We are the exception. We are the ones who got out, and the 6 that stayed small did not fail at something the 3 of us managed. They simply never had the reason to open that we did. The idea belongs to 2 physicists, Robert Brandenberger and Qumran Vafa, and to a paper they published in 1989 with a title as plain as a door in a wall: Superstrings in the Early Universe. It is one of those papers that reads, in hindsight, less like an answer and more like someone finally asking the correct question out loud. And the picture it draws is so simple that you could almost fall asleep inside it, which, tonight, would be a fine thing to do. Imagine the whole of the young universe not as a smooth empty stage, but as a space threaded through with strings. Not strings as a metaphor, strings as the actual, literal, fundamental objects, the tiny vibrating threads that string theory says everything is made of, when you go down far enough. In the beginning there are countless of them, and the space they live in is wound up small in all 9 of its directions, curled around on itself, so that if you travelled far enough in any one direction you would come back to where you began. A space like that, closed and looped in every direction, lets a string do something it cannot do in open space. It lets a string wrap. It lets a string wind all the way around a dimension and join back to itself, like a rubber band stretched around a rolled poster, like a thread wound around your finger until it holds. And these wind strings, these winding strings, are the whole secret, because a dimension with winding strings around it cannot easily grow. The windings act like a grip. They tighten as the dimension tries to expand. They pull it back down. They hold it small the way the elastic holds the poster rolled. For a direction of space to open, to unwind, to become large and roomy and free, the windings around it have to go away, and there is only one way for a winding to go away. It has to meet its opposite. A string wound one way around a dimension has to find a string wound the other way, and the two have to touch, and when they touch they cancel. They unwind each other, they release their grip, and they release their energy, and only then, only where that has happened, can a direction stretch out and become a place you could live in. So now the entire fate of the universe, the whole question of how many dimensions you would one day find yourself inside, comes down to a single quiet matter. How easily can two strings find each other and touch? Not a matter of law handed down from above, not a matter of choice, a matter of meeting. And this is where the loophole, the fragile and beautiful loophole, opens up, because whether two threads can reliably find each other turns out to depend on exactly one thing. It depends on how many directions they have to get lost in. Think of two people wandering. If they are confined to a single line, a hallway with no branches, they cannot help but meet. They are coming straight at each other with nowhere else to be. Give them a flat floor, two directions to roam, and they can still cross paths, though now they might wander a while first. But lift the ceiling, give them a third direction, height, a whole volume to drift through, and meeting becomes rarer, chancier, a thing that happens but is no longer guaranteed. And here is the mathematics of it, told as gently as it can be told. There is a clean, hard fact about threads moving through space, a fact of pure geometry with no physics in it at all. Two one-dimensional things, two strings, two threads, will reliably cross and meet only when the space they move through has 3 dimensions or fewer. 3 or fewer, and they find each other. They collide, they cancel, they release their hold. 4 or more, and they slide past. They miss. They wander forever in a space too wide to force a meeting, and their grip never loosens, and the dimension they are wound around never gets to grow. Do you feel the shape of it? Not a rule that says 3, not a number written into the foundations of things. A number that falls out, quietly, from the simple question of where a thread can find another thread. In 3 dimensions or fewer, the windings meet, they annihilate, they let go, and those directions are set free to expand into the wide open space you are lying in tonight. In 4 dimensions or more, the windings never meet, they never let go, and those directions stay clamped, small, curled, hidden. Exactly 3 get to open. Not because 3 was chosen, because 3 is the largest number of directions in which a thread can still be sure of finding its partner. 1 more, and the meeting fails. 1 more, and that dimension stays folded down with the others, below every instrument we will ever build. And I want you to notice what has just happened to the dread, because it has changed its color without changing its weight. Before, the fear was of hiding. The fear was that the universe was full of secret rooms we could not enter, doors we could not find, and that our 3 little directions were a small lit clearing in an enormous dark house. That fear was about being surrounded by what we cannot see. This new fear is different. It is not about the hidden, it is about the arbitrary, because if 3 is not a law but an outcome, if 3 is just the number that happened to win a race between colliding threads in the first faint instant of everything, then 3 is not sacred. 3 is not necessary. 3 is not the way space had to be. It is the way space turned out, once here, under conditions that could perhaps have gone otherwise. And every solid thing you have ever touched, every stable atom, every closed orbit, every molecule holding its shape long enough to become a cell, and then a body, and then the quiet listening mind you are resting in right now, all of it sits on top of that outcome. On 3 threads happening to meet. You do not have to decide tonight whether that is a comfort or a terror. It can be both, and you can hold both loosely, the way you are holding this whole slow story, without gripping any of it. Let your shoulders come down from wherever they have crept. Let the number 3 stop being a fact you are trying to keep and become just a sound moving through the dark. Because the winding strings give us a mechanism, at last, a real physical reason where before there was only a coincidence dressed up as a law. But a mechanism is not a proof. And the moment you have a mechanism, a story of how it could have happened, a much harder and much colder question steps forward out of the dark behind it and quietly asks to be looked at. The question is this: if 3 directions won, then where are the other 6? Not gone. That is the first thing to let go of, gently, the way you would set down something you had been carrying without noticing you were carrying it. When the winding strings found each other and let 3 dimensions swell outward into the room you are lying in, nothing in that story reached back and deleted the rest. The 6 that stayed small did not leave the universe. They did not travel somewhere else. They simply never grew. And a thing that never grew is not a thing that is absent. It is a thing that is folded. This is where almost everyone quietly gets it wrong, and it is worth stopping on, softly, before we go any further down. When you hear that space has 3 dimensions, it is natural to hear it as a full and final count. 3 and no more, the way a room has 4 walls and that is the end of it. But that is not what the mathematics is saying. The mathematics is not saying there are 3. It is saying that 3 of them are large. 3 of them opened wide enough for you to walk through, to fall through, to point down and say there, and up and say there, and across and say there. The others, if they are there, opened only a whisper. And a direction that opens only a whisper is still a direction. So the correction is small, and it changes everything. It is not that the universe has 3 dimensions, and the extra ones are a fantasy dreamed up to keep string theorists busy. It is that the universe may have 9, or 10, and you can only ever see the 3 that had room to become visible. Not absent, curled, not removed, reduced, not somewhere far away at the edge of the sky, but right here, at every single point, threaded through the very space your hand is resting in, wound too tightly for anything you are made of to enter. Let that sit for a moment. You do not have to believe it. You only have to let it be one of the possibilities in the dark, one shape among several, resting there without needing to be chosen. Because here is the size of the fold, and this is the part that is hard to feel and easy to say. When Oscar Klein first tried to explain, back in 1926, why we cannot see the extra direction that Kaluza had smuggled into Einstein's equations, he did not say it was far. He said it was small. He gave it a radius, a circle so tight that light would go round it and come back to where it started almost before it had gone anywhere at all. And the size he landed on was roughly 100 billion times smaller than a single proton. A proton, already a thing you will never see. A thing so small that naming it is a kind of guess. And this hidden circle would be smaller than that, by a factor with more zeros than you would want to read aloud in the dark. About 23 times the very smallest length that physics believes means anything at all. So picture it, if you can, though the picturing will fail, and that is fine. Let it fail. At the tip of your finger, at the center of your chest, in the space between one slow breath and the next, there is not only the up and the down and the side to side that you know. There may also be, at that same point, a tiny closed loop of extra direction, wound so small that no atom in your body has ever been able to move along it. You are not standing outside these dimensions. You are standing inside all of them. You simply cannot go there. They are the rooms in the house that are too narrow for any door. And now you can feel the cold of the harder question. Because if the extra dimensions are not gone, if they are only small, then 3 is no longer an answer. 3 is only a report. 3 is only the number of directions that happen to grow, in this universe, along this particular history. It stops being a law of what must be, and becomes a fact of what did happen. And a fact of what did happen could, in another telling, in another cooling, in another throw of the same early dice, have come out as 4, or 2, or some number no living thing could ever have been around to count. This is the turn, and it is worth naming plainly. Everything we walked through in the first hour, the orbits that could not close in more than 3 dimensions, the atoms that could not hold, the chemistry that could not begin, all of it was an argument about why we could only ever find ourselves in a universe with 3 large dimensions. It was an argument about the observer. It never once said that 3 was the only number the universe was allowed to make. It said that 3 was the only number the universe could make us in. Those are not the same statement. They feel the same at 2 in the morning, but they are not. One is a promise. The other is only a filter. And a filter is a colder thing than a promise. A promise says the universe is built this way, on purpose, and could be built no other. A filter says the universe may be built every way at once, and you are simply reading the one page you were printed on, and the pages where the orbits collapsed and the atoms fell apart have no one on them to turn them, and so they stay closed, and quiet, and unread, forever. You can hold this without it hurting. That is the strange gift of hearing it lying down, in the dark, with nothing you need to do about it. Somewhere in the mathematics there may be a version of the beginning, where 4 directions 1 instead of 3, and in that version there is no you, no bed, no slow voice, no one to be troubled by the number 4. There is nothing there to be troubled at all. So the very fact that you are here to hear that 3 is strange is the reason 3 could never have felt like anything else. You could only ever have woken up inside the answer that allows waking up. Let your breathing slow with that, not away from it. Let your shoulders keep coming down. You do not have to solve it. It is not a problem set on your chest for the night. It is only the shape of the thing, seen a little more honestly than before, and you are allowed to set it down whenever you like. But notice what has quietly happened while we were looking. We began the night asking why the universe has 3 dimensions, as though the number were a fixed truth waiting to be explained, and the winding strings and now the folding have turned that question slowly inside out. The number may not be fixed at all. It may be one outcome among many, chosen not by a law but by a process, and then made to look inevitable by the simple fact that only the 3-dimensional outcome ever grows anyone to ask about it. Which means the real question was never why is it 3. The real question, the one that has been waiting underneath the whole time, is whether anything about it was ever forced at all, or whether the whole thing could just as easily have gone another way, and we are only ever the ones who happen to land on the page where it did not. And that is where the night deepens, because if the number could have gone another way, then somewhere, at some moment, it did not. Somewhere in the first unimaginable instant, before there were atoms, before there was anything you would recognize as light, the choice was made, and then it was kept. Not decided by anyone, not written into any law you could point to, just settled, the way a thing settles once it has finished cooling. And you are lying here now, breathing slowly, inside the result of that settling, wearing it like the shape of your own body. There is a way of looking at this that makes the settling almost gentle, and it comes from a quiet paper published in the spring of the year 2016. 3 physicists, Julian González Ayala, Ruben Cordero, and Fernando Angulo Brown, working between the University of Salamanca in Spain and the National Polytechnic Institute in Mexico, asked a question that sounds almost too simple to answer. Not why is space stable in 3 dimensions, not why do orbits hold. Something plainer than either. They asked whether 3 was, in a certain sense, the most comfortable number for a young universe to be, whether the cosmos, as it called, might have slid toward 3 the way water slides toward stillness when you stop stirring it. To do this, they tracked a single quantity through the earliest moments of expansion. It carries an intimidating name, the Helmholtz free energy density, but you do not need the name to feel the shape of what it does. Think of it as a kind of pressure, a bookkeeping of how energy and heat are balanced in a given space. And what they found is that this pressure, followed across all the possible numbers of dimensions, reached its first peak, its first natural high point, at exactly 3. not near 3, not somewhere in the neighborhood of 3, at 3 itself. And then they found the second half of the thought, which is the part that reaches all the way down to where you are lying. Below a certain critical temperature, in the units of their own model, the universe did not merely prefer 3 dimensions. It became locked into them, fixed, set. The way liquid water, once it falls below freezing, does not gently drift back and forth between water and ice, but crystallizes and holds and cannot unmake itself unless something heats it again. Above that temperature, the number was still soft. It could still have moved. Below it, the number set like frost across a window in the night, and the universe never grew that hot again. So the frost never melted. It is still there. It is the space you are lying in. They wrote, carefully, that this was the first time the number 3 of the space dimensions had arisen as the optimization of a physical quantity. Not chosen, not designed. Optimized, the way a river optimizes its own path down a hillside without ever meaning to. And if that is true, then the 3 dimensions around you are not a decree. They are a low point. A settling, the place a cooling universe rolled to and stopped. You can let that idea rest on you as gently as it wants to. There is nothing here to hold on to, nothing to memorize. Just the strange softness of learning that the frame of everything you have ever moved through may be less a law than a habit the cosmos fell into once, in the cold, and never broke. Now let the frame widen, because there is another way the everyday hides its own mathematics from you, and it is closer than the early universe. It is in your hand, if you lift it. Consider how weak gravity actually is. You do not usually think of it as weak. It is the thing that keeps you in the bed, the thing that makes the climb up the stairs cost something, the thing that eventually pulls everything back down. But set a small magnet against a paperclip on a table, and that little magnet, a thing you could lose in a drawer, lifts the paperclip clean off the surface. In that one small motion, the pull of a scrap of metal has beaten the gravity of the entire Earth, the whole planet, every mountain and ocean of it, pulling downward, and it loses, instantly, to something you could hide in your palm. That is not a curiosity. That is one of the deepest unsolved strangenesses in all of physics, and it has a name that sounds like an accountant's complaint: the hierarchy problem. Gravity is not just a little weaker than the other forces. It is weaker by an amount so vast that the words for it stop meaning much. The gap runs to something like 16 orders of magnitude, a 1, followed by 16 zeros. 10,000 million times feebler than the force that holds your atoms together. And physics, for a long time, had no honest reason why. Why would the force that shapes galaxies be, at close range, the softest, faintest, most easily overruled thing in the universe? In the year 1999, 2 physicists offered an answer that turns the whole question of hidden dimensions inside out one more time. Lisa Randall and Raman Sundram. And what they proposed was not that gravity is weak because it is small. It is that gravity is weak because it is leaving. Because most of it is somewhere you cannot go. Picture our entire universe, everything, every star and every breath, as a single thin sheet. A surface. They called it a brain, from the word membrane, and the idea is that all of matter, all of light, all of you, is stuck to that surface, unable to step off it. But gravity is different. Gravity in their picture is not confined to the sheet. It can reach into the space around it, into a further dimension the rest of us can never enter. And so when gravity spreads out from a mass, it does not all stay here with you. Some of it bleeds away, off the sheet, into that other direction, thinning as it goes. What you feel, the weight in your legs, the pull on the falling cup, is only the part that stayed behind. The version of their idea that unsettles most quietly is the second one, published the same year. In it, the extra dimension is not tiny, not curled into some invisible circle. It is infinite. It goes on without end, and yet you would never know, because gravity, though it can enter that endless space, is gathered so tightly against our own surface that it barely leaks at all. The mathematics they use describes it as a kind of peak, a sharp crowding of gravity right at the sheet where we live, falling away steeply the moment it tries to leave. So the strangeness is not that the hidden dimension is too small to matter. The strangeness is that it could be as large as forever, and we would still stand here feeling nothing but the faint edge of a force that is mostly elsewhere. Let that settle for a moment, because it is a heavier thought than it first sounds. It means the weakness you feel in gravity, the reason a magnet beats a planet, the reason you are not crushed flat against the floor of the world, may be a measure of how much is being lost. A constant silent draining. Every falling thing, every orbit, every slow settling of your own weight into the mattress is only the remainder. The part that did not slip away into a place your hands will never reach. Not because the place is far, because you are made of the wrong kind of thing to go there. And here is where the dread grows quiet and enormous at once. Those hidden directions, whether there is one of them or 6 of them, whether they are frozen small or stretch out forever, are not off at the edge of the universe. They are not out past the last galaxy, waiting to be travelled to. They are here, at the tip of your finger, in the space between your resting hand and the sheet beneath it. At every single point of the room you are lying in, folded so tightly or peaked so sharply against our surface that you have moved through them your entire life without a single nerve ever reporting them. You have always been surrounded. You are surrounded right now, not by distance, by dimension. So notice what has stacked up while the night deepened. It is not only that 3 may be an accident of cooling rather than a law. It is not only that the number froze once and could not thaw. It is that even the 3 you have are not the whole shape of the space you live in. Something is folded in beside them, at every point, unchanged since the first instant, patient in a way that has nothing to do with waiting. And the weakest force you know, the gentle pull that will one day lay you all the way down, may be weak precisely because it is forever slipping out of your world into theirs. You do not have to carry any of this. Let your shoulders come down from wherever they have crept. Let the breath go long and unhurried. None of these dimensions require anything of you tonight. They asked nothing of you when you were born into them, and they will ask nothing of you now, as your thoughts begin to loosen at the edges. But stay with me a little longer, because there is one more layer beneath even this. One last turn where the folding and the leaking and the freezing all come to meet, and it changes, very softly, what it might mean that you are the one lying here to notice them at all. Stay, then, and let the thinking mind wander where the tired body will not follow, because the strangeness does not end with what is folded quietly beside you. It runs backward, into a time long before there was any you to run it, and it runs forward, into a dark so far ahead that the word future stops meaning very much. Consider how early all of this was settled. Not settled by anyone, not chosen, not drawn up, not argued into place across a table, only settled, the way still water finds the lowest part of a room while no one is there to watch it happen. In the first unimaginable instant, when everything was small and hot and wound tight, there was no reason yet for 3. There were 9 directions, and every one of them was equal to every other one. Nothing marked any of them as special. Nothing pointed and said, you and you and you grow large, and the rest of you stay folded away forever. And here is the part that sits so strangely once you let it in. The 3 you live in did not win because they were stronger. They won because of a quiet accident of shape. In that earliest moment, the story physics tells is that the whole of space was threaded with strings wound around itself, like rubber bands looped again and again around a narrow cylinder. And a wound thing can only come undone if it meets another wound thing and lets go. That is the whole of it. 2 of them have to find each other, and there is a plain, almost childish fact about finding. A fact that has nothing to do with luck or will. In more than 3 large directions, 2 lines drawn through space will generally pass each other without ever touching. They slide by in the roominess of all that extra room and simply never meet. Only in 3 large directions, or fewer, are 2 such lines crowded enough to collide, so 3 could come undone. 3 could release their tension and stretch out and become the wide, cool, star-scattered space you are lying inside of tonight. And the other 6 could not. Not because anything held them, not because a hand closed around them and refused to open, but because nothing ever came to release them. They are small tonight for the same reason a knot stays tied when no one pulls the ends. That is not cruelty, it is not design, it is only geometry, doing the one thing geometry does, which is to be true whether or not anyone is watching. There was a moment for the 3, as far as the mathematics can tell. A kind of hinge in time, when a computer was made to begin from perfect 9-fold sameness, from a space with no favourite direction at all, and simply allowed to unfold on its own. It did not stay even. At a certain instant, which the physicists called a critical time, 3 directions broke away from the other 6 and began to swell, and the perfect symmetry among all 9 came apart in the swelling. It was not pushed, it was not tuned by hand toward the answer anyone wanted. It fell into 3 the way a pencil balanced perfectly on its point must, sooner or later, fall in some one direction, even though every direction was the same until it fell, and the number it fell into was ours. You should feel how thin that is. Not thin like fragile, thin like a single line drawn once, in a place where it could as easily not have been drawn, and never drawn again. And then, as the young universe cooled, something closed behind it like a door swinging shut in a house you have already left. There is a way of accounting for the pressure that space itself feels as it cools, a kind of ledger of energy pressing outward on the shape of things, and when that ledger is worked all the way through, it reaches its highest point, its most favoured, most settled value, at exactly 3 large dimensions. Below a certain temperature, the universe stopped being able to choose. It became, in the plain word the researchers used, locked. 3 was not a preference it kept revisiting. 3 was where it froze and stayed. This was, they noted quietly, perhaps the first time anyone had watched the bare number 3 of the dimensions of space arise, not as an assumption written in at the start, but as the answer to something being made as small or as large as it could be. The universe was solving a problem it did not know it had, and the solution was the room you are breathing in. So let the negatives stack, gently, one soft weight upon another, and do not brace against them. It is not that 3 is likely, it is not that 3 is natural, or obvious, or the only thing that could ever have been. It is not that some law reached down and insisted on it. It is that 3 is what was left standing after the winding failed to unwind in the rest, after the symmetry fell where it fell, after the cooling froze the ledger at its one high value and threw away the key. Take any one of those away, and there is no chemistry. Take any one of them away and the slow rise of your chest does not happen, because the atoms that make the muscle that lifts it cannot hold their electrons in place, cannot form the long patient chains that remember how to be you from one heartbeat to the next. You are not the center of this. You are the thing that could only have appeared in the corner where all of it happened to hold. That is a lonelier fact and a warmer one at the same time, and you are allowed to feel both, or neither, or to feel nothing at all, and simply let the words move over you like slow water. And the 6 is still here. That is the part that reaches forward into the far dark. They did not leave when the 3 grew large. They stayed exactly as small as they were in the first instant, curled tighter than anything you have a word for, tighter than the space inside the smallest piece of the smallest thing you could ever name. They will be that small tonight, and that small when the last star you could ever see has gone quiet, and that small in the long cold afterward when there is nothing left moving anywhere to notice them. They do not age, they do not open. They kept their shape while everything you have ever loved was assembled and worn down and let go, and they will keep it after. And the faint pull that holds you to the floor, the weakest thing you know, the one that will one day lay you all the way down and keep you there, may be weak for no grander reason than that it is forever thinning itself out into that folded elsewhere, forever spending a little of its strength into rooms you will never enter. You do not have to hold any of this. Let it be heavy somewhere that is not your shoulders. Let the jaw unclench. Let the number 3 and the 6 beneath it, and the long freeze that fixed them, drift past you the way a train passes a window in the night, lit and enormous and already gone. None of it is asking you to stay awake. It managed the whole of its arrangement without you, in a dark far older than sleep. But keep the smallest thread of attention with me a moment more, because underneath the folding, and the leaking, and the freezing, there is one last turn still waiting. One place where all 3 of them fold quietly together into a single stranger idea, and it changes, very softly, what it might mean that of all the corners where nothing at all could have happened, this is the one that made something able to lie here and know it. But before we follow that turn, there is one more thing to tell you, and it is the most human thing in this whole long story, because it is the moment when people stopped only thinking about the hidden dimensions and decided, at last, to go looking for them. For 70 years the extra rooms had lived only on paper. A curl of a dimension inclines equations, 6 shapes folded away in the string theorist's imagination, a warped 5th direction in the mathematics of the brain. All of it deduced, none of it seen. And there is a particular ache in that, if you let yourself feel it. To build an entire architecture of the universe out of pure reasoning, and never once to touch the thing you have built. So they built a machine instead, not to reason about the hidden rooms, but to knock on their doors and listen for an echo. The machine sits under the border of France and Switzerland, in a ring of tunnel 17 miles around, buried deep enough that the fields and the villages go on above it without ever knowing. It is the largest instrument our spaces has ever made. Inside it, protons are driven around and around, until they are moving at very nearly the speed of light, and then 2 streams of them are steered into each other, head-on, so that the energy of the collision folds down into a single point smaller than anything you have a word for. And in that point, for the smallest sliver of an instant, the universe is made briefly as hot and as dense as it was in the first fractions of a second after it began. You could think of it, if you like, as a way of asking the early universe a question directly, by rebuilding a speck of it and watching what falls out. And here is where the hope came in, quiet and real, because the brain world picture, the one you have just been carried through, made a promise the older theories could not. If gravity is weak only because the graviton is spread thin, leaking most of its strength out into that folded elsewhere, then the graviton is not truly gone. It is out there in the bulk, and a version of it, a heavier echo, might be shaken loose if you hit the vacuum hard enough. The strange weakness of gravity, in other words, might not be a wall, it might be a window. For the first time, the hidden dimensions were not merely a thing to be argued about. They were a thing that a machine, in our lifetimes, might actually make ring. Somewhere in the debris of a hard enough collision, a particle could appear that had no business being there, a resonance heavier than anything the ordinary 3 dimensions allow, and it would be the first physical evidence, the first genuine fingerprint of a room we could never enter. You can feel how much rode on that. 70 years of pure thought, waiting for a single bump in the data to say, yes, you were right, they are real, they are here. So they looked. Through the years of 2016 and onward, into 2023, 2 enormous detectors wrapped around 2 of the collision points. Machines called by their initials watched hundreds of trillions of these collisions and sifted the wreckage. They looked for the graviton's signature in pairs of photons flung out back to back. They looked for it in pairs of heavy particles and in the spray of matter that a collision throws sideways. They were looking for a shape in the noise, a swelling at some particular energy where a hidden resonance would pile up, the faint heavy shadow of a particle that had leaked in from the bulk. Year after year, they tuned the search finer and pushed the energy higher and combined the data and looked again. And they found nothing. I want to be careful with that word, because in this science, nothing is not the same as no. Nothing does not mean the extra dimensions are not there. It means only that if they are there, they are not there in the way that would have been easiest to find. The searches did not close the case. What they did was draw a line, and then push the line steadily upward and say, below this energy at least, there is no graviton hiding. By the most recent reckoning, the heavy graviton of the brain models is ruled out below roughly 2 trillion electron volts for the faintest coupling, and pushed up toward 3 and 4 trillion electron volts for the stronger ones. The related picture, the one with large hidden dimensions, is pushed back past 3 and nearly 4 trillion electron volts as well. And a trillion electron volts is a strange unit to feel in the body, so let me only say this. It is more energy than the machine had ever reached before, concentrated into a space far smaller than an atom, and across every scrap of that reach, the door that might have opened stayed shut. There is a particular flavour of disappointment in a result like that, and it is worth sitting with for a moment, gently, because it is the honest shape of how we know things. The hope had been a window. What came back was a silence, not a slammed door, not a refusal, just a quiet that could mean the rooms are folded smaller than we guessed, or heavier than we can reach, or arranged in some way the simple models never imagined. Remember Klein's number, the fifth dimension curled to a circle 100 billion times smaller than a proton. If the truth is anywhere near that, then no machine we have built, or are likely to build, comes within 13 orders of magnitude of touching it. The great collider under the mountains, for all its miles and all its cold and all its power, still probes a world some 10 million billion times too large to feel that curl. The searching was real, the instruments were extraordinary, and the answer they returned was the most patient answer of all, which is, not here, keep looking, we do not yet know. You do not have to carry the weight of that either. Let it be someone else's vigil, in a control room lit blue at 3 in the morning, watching the counts come in. You can let your own attention go loose around it. The universe was not waiting on the collision to decide how many dimensions it would have. It settled that question in a dark so early that the machine and the mountains and the border it runs under and you are all very late arrivals to a room whose shape was fixed long before there was anyone to measure it. But here is where the threads begin, very slowly, to gather, because look at what we are left holding. The folding, first, the 6 directions curled away so small that no light and no matter and no collision we can make will ever resolve them. The leaking, second, gravity thinned and spilled into that hidden elsewhere until it is the faintest force we know, a whole force reduced almost to a rumour. And the freezing, third, the early cooling that locked the count at 3 and let the rest stay small. 3 separate answers from 3 separate corners of physics, arrived at by people who often were not even speaking to one another across the decades. And now, from the machine, a 4th thing. A silence that neither confirms the rooms nor sends them away, but leaves them exactly where the reasoning put them, just out of reach, just past the edge of what we can touch. And when you set those 4 things side by side, in the quiet, something odd begins to happen to the question itself. For most of this long night, we have been asking it one way. Why 3? Why not 4? Why not 9? Why not the 11 that the deepest theory seems to want? We have been treating 3 as a thing to be explained, a number that needs a mechanism, a lock that needs a key. And the folding, and the leaking, and the freezing, and the machine's long silence have each in their own way handed us a piece of that key. But underneath all of them, so quietly that it is easy to miss, a different question has been forming, and it turns the whole thing inside out. It is not, why did the universe choose 3? It is, in a universe that chose 3, who is left to ask. Because the same number that lets an orbit close is the number that lets an atom hold. The same 3 that keeps the electron from spiraling into the nucleus is the 3 that lets molecules grow long and complex and strange enough to carry information, to fold into a strand that copies itself, to build a cell, and then a nerve, and then a slow, warm animal that can lie in the dark and wonder about the shape of the space it is lying in. Ehrenfest saw a corner of this back in 1918, when the whole subject was young. 3 is not merely the number where the equations behave. It is the only number where a thing capable of asking the question can exist at all. And that turns the silence from the great machine, and the folding and the leaking and the freezing, into something far stranger than a set of separate facts. It begins to look as though they are not 4 answers to 4 questions, but 4 faces of a single one, and the single one is not really about dimensions at all. It is about why there is anyone here to count them. And so, lying there, you can hold the whole strange assembly at once, one idea resting gently on the next. There is the freezing. The thought that the cooling universe settled into 3 the way still water settles into ice, taking on a shape it can never again shed. There is the leaking. The picture of everything you are as a thin skin floating in a room with one more direction than you will ever point toward. Gravity alone faint enough to drain off its edge. And beneath both, older and quieter, there is the arithmetic Paul Ehrenfest set down in 1918, murmuring that whatever the mechanism, only 3 could ever have held a creature able to notice it. For a long time these felt like rival tales, each reaching for the same prize from a different side of the room. Yet the further in you go, the more they begin to lean against one another, until you can no longer be sure where one ends and the next takes its weight. The machine that counted, the simulation that watched 3 directions swell out of 9, does not argue with the membrane. The membrane does not argue with the winding strings, and none of them argue with Ehrenfest, because his was never a claim about how the number was chosen. It was only a claim about which numbers leave anyone behind to ask. Here is where a small warmth enters, if you want to hold it. For all its dread, this picture leaves a door open. If the extra dimensions are real but folded, or real but leaking off a membrane we are pinned to, then they are not gone. They are near. Nearer than the next room, nearer than your own skin, wrapped so tightly around every point in the space you are lying in that they hide by being everywhere. And a thing that is near can, in principle, be found. That is the tiny hope. Somewhere under Geneva, in a ring of magnets some 17 miles around, kept colder than the space between the stars, protons are driven almost to the speed of light and flung into one another. And in the debris of those collisions, physicists have spent years watching for a single sign of the hidden shape. A particle that flickers into existence and then, impossibly, carries away more energy than it should, as though some of it had slipped sideways into a direction we cannot follow. The faint fingerprint of a graviton that had leaked in from the bulk. They have looked in the light of 2 photons born together. They have looked in pairs of electrons, in pairs of the heavier cousins we call muons, in the wide sprays of particles they call jets. They have looked, patiently, through more collisions than there are seconds in 100,000 years. And so far, the answer that comes back is silence. No graviton has stepped out of the 5th dimension. If the particle Lisa Randall and Raman Sundram imagined exists at all, it is heavier than roughly 4 trillion electron volts, which is to say heavier than the machine has yet been able to reach. The large extra dimensions that some had hoped for, the ones that might have made gravity weak by giving it room to spread, have been pushed back and back, ruled out down to scales of a few trillion electron volts, and still nothing has appeared in the gap. Rest on that for a moment, because it is a strange kind of result. The most powerful instrument our species has ever built, a machine that reaches down to lengths of about 10 to the minus 17 centimeters, has stared into the smallest distances it can resolve and seen no extra dimension there. And yet this proves almost nothing, because Klein's fold, if it is real, is smaller still, so much smaller that the collider is more than 10 trillion times too coarse to feel it. We have searched the largest hiding places and found them empty. The smallest ones remain exactly as hidden as they were a century ago, when a young man wrote a letter to Einstein about a 5th direction and had to wait 2 years for a reply. So the hope and the dread arrive folded into the same fact. The dread is that the silence may simply mean the dimensions are curled beyond any reach we will ever build. That the question of why there are 3 could be sealed away behind a wall 13 orders of magnitude thick, a wall no accelerator the size of a city, or a country, or a world could ever breach. The hope is quieter and will not let go. It is that silence is not the same as absence. Every year the searches grow finer. Every year the wall is pushed back another sliver, and the theories themselves keep sharpening, keep making the kind of narrow, testable promise that could one day be caught in the very act of coming true. None of this you need to carry. Let it be enough tonight to know that the question is still open, that somewhere people are still looking, that the not knowing is a live thing and not a closed door. Let your shoulders go heavy against whatever is beneath them. Let the trillions and the fractions of a centimeter drift off like numbers read aloud in another room. They will keep without you, because here is the thing the whole layered picture has been circling toward. The reason all of these threads keep tightening into one. Notice what every explanation has in common. The freezing chose 3. The winding strings left 3 free to grow. The simulation watched 3 break loose from 9. The membrane floats in a bulk of who knows how many, and pins us to a sheet that is, once again, 3 directions wide. 4 different answers, drawn from 4 different corners of physics, by people who in some cases never met, working decades apart, in different countries, in different languages. And each one, coming at the question from its own strange angle, arrives at the same small number, the same 3 you can measure right now, by lifting a hand and moving it up, and then across, and then away from you, and finding that there is nowhere left to go. That agreement should comfort you, and in a way it does, but it also opens something wider underneath, a question these theories were never built to answer, and cannot, on their own, close. They can tell you, each in its own tongue, how the universe might have come to wear 3 dimensions. Not one of them can tell you why the universe is the kind of thing that had to choose at all, or why the choosing landed on a number that would let a warm and breathing witness rise up inside it, long after the choice was made, to lie in the dark and count the directions back. So let that question stay where it is for now, unlifted, resting in the dark a little to the side of you, the way a heavy thing you have decided not to carry tonight can simply be set down on the floor beside the bed. There is no failure in a question that stays open, and the strange comfort, the thing worth taking down with you into sleep, is not that we are missing an answer, it is that we have gathered so many, and that they do not quarrel with one another the way you might expect. They point, from their separate corners, at the same quiet number. Perhaps the 3 is 3 because of the strings. Perhaps, in that first unimaginable pressure before there was any room to speak of, every one of the 9 directions was wound as tight as the others, each one small, each one wrapped around by loops of energy pulled taut, like rubber bands around a rolled sleeve. And perhaps those loops could only ever find each other, meet, and cancel, in a space no wider than 3. So the 3 loosened, and let go, and unrolled themselves into the vastness you are lying inside of, while the other 6 stayed knotted and hidden, too small to notice, too small to enter. Perhaps you are large tonight because 3 dimensions were the only ones that could ever untie. Or perhaps the 3 is 3 because the universe, as it cold, went looking for a flaw and found one. Perhaps there is a kind of pressure woven into the fabric of empty space itself, a pressure that rises as space takes on more directions, climbs and reaches its very highest point at exactly 3, and then falls away again on the far side. And perhaps the young universe, dropping through temperature after temperature, slid down toward that peak, the way water slides toward the lowest ground it can reach, and then goes still. It settled into 3 the way a tired body settles into a mattress. It came to rest there because there was no reason left to move. Below a certain warmth it was simply locked, and the locking was gentle, and it has held ever since. Or perhaps the 3 is 3 for a reason even barer than that. Perhaps 3 is only what a certain honest arithmetic does when you let it run all the way out and refuse to touch it. Give a machine 9 directions, all of them equal, none of them favored, no thumb resting on any scale, and let the equations of a 9-dimensional quantum world grind forward through 1,000 small steps. And watch what happens at the moment the simulation calls its critical time. 3 directions come apart from the others and begin to grow. Not 4, not 2, 3. The perfect balance of the 9 breaks. The way a pencil balanced on its point cannot stay balanced and must fall in some one direction. And when it falls, 3 is the number left standing. Perhaps our universe is nothing more mysterious than a pencil that had to fall and fell toward us. Or perhaps, and this is the plainest thought of all, and in some ways the coldest, perhaps there is no mechanism worthy of the word. Perhaps 3 is not chosen and not caused. Perhaps 3 is only the single shelf, in a library too large and too dim to walk, on which a thing like you could ever come to stand and read the titles. In one dimension there is only a line, and a line has no room to hold a knot, and you are, among many other things, a vast and warm arrangement of knots. In 2 dimensions, the forces that reach across space grow too weak too fast, and nothing binds, and the tube that would carry food through a flat creature would also cut it cleanly in 2. In 4 dimensions, or 5, or any of the higher numbers, the pull between an electron and the heart of its atom no longer fades as a gentle inverse square, but plunges as an inverse cube or steeper, and every electron spirals inward and is swallowed, and there is no chemistry, and there is no slow rise and fall of a chest in the dark. Only in 3 does matter agree to hold together, and also agree to build. So perhaps the reason you find 3 when you lift your hand and move it up, and then across, and then away, is simply that in any other number of dimensions there would be no hand, and no lifting, and no one to be surprised. The 3 did not bend toward you. You are only what 3 permits. You do not have to choose among these tonight. That is the first thing to set down beside the question. Nobody has chosen. The people who spent their lives on this, in Amsterdam and in Berlin, in Osaka and in Salamanca, working in different tongues and different decades, most of them never in the same room, have not settled it, and they know they have not, and they carry it more lightly than you might think. Because not one of these pictures has yet been caught in the act. No instrument has reached down to the size where a curled dimension would live and touched its edge. The great ring beneath the border of France and Switzerland has swung its beams together countless millions of times, hunting for the faint print of a dimension leaking energy away where no energy should go, hunting for a heavy ghost of the graviton falling in from some hidden direction, and it is found, up to the enormous energies it can reach. Nothing, only silence, and a floor placed a little lower each year beneath where the answer is allowed to hide. The dimension that theory keeps needing has kept, so far, out of every net we have known how to weave, and that is not a defeat. Let that be the second thing you set down. It is only the shape of a real frontier, which is never a wall you arrive at, but a horizon that keeps its distance as you walk. The machine that could see a rolled dimension 100 billion times smaller than a proton has not been built, and may never be built, and the fact that we can say clearly what it would have to do is itself a kind of quiet triumph. We have narrowed the dark, we have drawn the edges of our own not knowing with a fine and steady pen. 100 years ago, the question of why space wears 3 directions was not even thought to be a question. It was simply the water the fish forgot it swam in. And now it is a thing with a history, with rival answers, with numbers attached, with experiments that have looked and reported back. To have turned an invisible assumption into an open and honest problem is most of the work. The rest can wait. The rest can wait until long after you are asleep, and long after the morning, and long after all the mornings you will ever see. So hold it however you like. That is yours to decide, and only yours, and you may decide it differently on different nights, and never be wrong. You may take the winding strings, and let the 3 be a knot that came untied. You may take the cooling and the floor, and let the 3 be a resting place the universe slid down into and could not climb back out of. You may take the falling pencil and let the 3 be the accident that balance always becomes. Or you may take the barest reading and let the 3 be nothing but the one narrow door through which a listener could ever arrive. You are allowed to find all 4 of them beautiful. You are allowed to believe none of them fully and love the question more than any of its answers. Nothing here asks to be resolved before you rest. The number is 3 whether you understand it or not. It was 3 before anyone asked, and it held you up through every hour of this long night without waiting for your permission, and it will go on holding you, unbothered, unhurried, whether you carry a theory of it into sleep or carry nothing at all. Let your grip on it loosen then, the way your hand loosens on the edge of a thing when you are almost gone. You do not need to keep the strings and the floor and the falling pencil separate in your mind. You do not need to keep the dates, or the names, or the small measured numbers we have laid down one after another across these 2 hours. Let them blur. Let them become one soft impression of a great many careful people, over a great many quiet years, all leaning toward the same small answer from their own strange angles, and all, in the end, agreeing that they cannot yet say the last word. Let that agreement be a hand under your back. There is nothing left for you to solve tonight. There is only the room, and the 3 directions of it, and your slow breath moving through them, up and across and away, and finding each time that there is nowhere further to go, and that nowhere further is exactly enough. Perhaps the number 3 is a law, written into the fabric of things long before there was anyone to read it, as fixed and as final as the speed of light. Or perhaps it is only an accident, one roll among countless others, and somewhere the strings fell differently and 4 directions opened, or 5 or 2, in a place that could never hold a listener like you to notice the difference. Or perhaps, and this is the gentlest thought of all, 3 is simply the shape that lets a thing wake up inside it and ask the question. Perhaps we count 3 because 3 is the only number that ever had anyone left over to do the counting. You do not have to choose between those tonight. That is the quiet freedom hidden in all of it. No one bent over a supercomputer in Osaka. No one writing a careful letter to Einstein in the spring of 1919. No one folding the mathematics of a rolled-up circle onto a page 100 years ago has handed you a verdict you are required to sign. They have handed you a room with the lights left on, and then they have gone home for the night, and the question is yours to keep however you please. You can believe it was written in. You can believe it was luck. You can decide, if you like, that it does not matter which, and that the not mattering is its own soft kind of rest. The answer belongs to you now, as much as it belongs to anyone, which is to say lightly, and without any weight you have to carry. And here is the thing to lean on, if you lean on anything. Everything that has ever existed, every star you have seen and every star you never will, every galaxy turning slowly in the long dark, the whole enormous reach of the observable universe, all of it has only ever needed 3 directions to be in. Length, width, depth, up and down, side to side, near and far. That is the entire stage. The most extravagant thing we know of, the cosmos itself, runs on the smallest workable count of dimensions that physics will permit, the bare floor beneath which nothing complicated could ever stand. It did not require 100 directions to make you. It required 3, and it spent all 3 on you. Let that be a comfort rather than a smallness. It would be easy, lying here in the quiet, to feel like a speck adrift in numbers too large to picture, and there have been a great many of those tonight. The folded distance smaller than a proton, the 9 directions, the trillion ways the early heat might have cooled. But the story does not end in your smallness. It ends in the plain strangeness that you are here at all, that out of 9 directions folded down to 3, out of winding strings finding each other in the dark and letting go, out of 1,000 ways it might have gone otherwise, a warm and breathing body came to lie in a still room, and wonder why the room has the shape that it has. That is not a reason for despair. That is the rarest thing the universe seems to know how to do, and it did it. And it did it as you. Gravity of sleep will be here, some other quiet night, when you feel like wandering out into another one of these long questions. But not now. Now there is nothing at all to reach for. Let the questions soften and go loose. Let the three directions hold you the way they have always held everything, without effort, without asking a single thing in return. You are exactly where the geometry meant to place you, which is nowhere special and everywhere at once, and simply here. Breathe in the length of the room. Breathe out its width. Let the depth of it carry you gently down, past the names, past the dates, past the last of the small measured numbers, into the plain dark that has no direction left to offer. And when the final thought goes, let it be only this easy one, that the universe, having just 3 ways to point, turned all of them, once, and briefly, and without reason, toward you.